All right, welcome back, fifth graders, to day 2 of our lessons on line plots. Yesterday, we had a pre-created line plot where the fractions were already placed in correct intervals down below the line plot. And as you take a look at this page right here, the second page of line plots, we are seeing that they give us a blank number line or a blank line plot that we need to figure out where to place our numbers. And just like with making a graph, guys, of any kind, a bar graph, a line graph, any of those types of things, we want to create consistent intervals. We want to make sure that we have the same gap and same space in between our lines so that we are consistent and we're showing incremental growth being the same way all the way across. So as I look at my fluency chart here, you can see that we have the lowest denominator that we have, or the smallest pieces that we break this up into, are eighths, and that would be my suggestion for where we start in creating our line plot. If you remember yesterday, we still do want to probably start with a 0. That makes the most sense just because, again, we usually start counting at that point. And then from that point on, I would suggest going up by eighths. Now, I could continue to just make them eighths, or I could convert them to their simplest form. So as an example, the next line here after the 1/8 could be considered 2/8, or another way to write that then would be 1/4. Either way would be an acceptable label for that one. The reason you might want to think about simplest form in this case is as we look at this fluency chart, you can see that there is no 2/8 there, that you would have to recognize that 2/8 is the same as 1/4. So just keep that in mind as you go forward in creating your line plots in the future, or if you see these line plots, going from 1/8 to 1/4 does not change our interval at all. We're still just going up by an eighth each time. So this one then, again, simplest form would be 3/8. The next one again would be 4/8, or if we looked at the simplest form, would be 1/2. Okay, again, looking over here, and you can see that these are in basic order in terms of how we are going up anyway with our breakdown of these numbers. So after 4/8, we end up with 5/8, and then the last one would be 6/8, or simplest form option of 3/4, which is represented down here. Now, yesterday as well, they just represented the frequency chart by using numbers. This one also shows us a different way to represent numbers, and we should be very familiar with the numbering system that they're using here, guys, since this is the numbering system that we use for the team points in our classroom. This is the tally system. Now, there's none of our tallies on here that make it to 5, but if you scroll down to the bottom of this page, you can see right here that there is actually a tally mark for the second question on this page that will get to the slash across at the number 5. So just be aware that sometimes we can represent these with other symbols other than just regular numbers. So now, the next step, guys, for this line plot is to actually input the data, actually set up the chart. I'm going to use X's today. I know yesterday we used circles or dots, and that's fine. I just feel like the dots are harder to space. They sometimes get uneven very quickly, whereas the X's stack a little bit nicer. So as I look at my chart here, I see that there are no or 0 1/8, so I can skip over that line. I can also then look at the 1/4 line, which in my number line here is also the 2/8, and I can make 2 X's going up on top of the 1/4. Then I can go over to the 3/8 and notice that there is one tally, so 1x. For the 4/8 or 1/2, there should be 3 X's. For 5/8, there should also be 3 X's, and then for the last row here, the 6/8 or simplest form of 3/4, there should be 1 X. So that is how we would lay out our line plot from that frequency chart. You do see that there is a blue line there, guys, and I'm going to erase just a little bit here to try and give ourselves some room here. Obviously, if that is the case, they are expecting us to write something in there, and more than likely what they want us to write in there is a title, is a label for that. And again, like in most bar graph situations or graphing situations, they're not trying to hide the title from you. They're just simply trying to copy this down. So this is the amounts, and I'm going to abbreviate a little bit here, that Toby ate each day. And then I'm going to put it in cups. Kind of sloppy there, sorry. But that's how I would label this line plot. Now, here again are some of the questions we can answer from that line chart down below here in A and B. It says, what is the total amount of food that Toby ate over the 10 days? Okay, so this is where using the line plot with the actual consistent denominator is going to make our lives a little easier, because now in this sense we've actually already created our common denominators, and we don't need to go all the way back to the fourths and the halves and those numbers. We can just go right from the eighths that we have in our number plot here, our line plot. Okay, so it says, what is the total amount? Again, the word total in this instance, since they are not happening each and every time and they are not equal and going up, we're not going to use multiplication, or at least not just multiplication. There's going to be a lot of addition that takes place here. So guys, remembering that I can't just add the numbers in this line plot, I've got to add the numbers in the line plot as many times as they show us here. So we should eventually end up with 10 numbers that we are adding together, since there were 10 days that we were adding these numbers. So when I am adding here for the 2/8, I will have 2 of those 2/8. So 2/8 plus 2/8 gets me to 4/8. So after this part of the column right here, I am at a total of 4/8. Then I'm going to take that 4/8, I'm going to add it to the next column, which would be 3/8. Right here, and there's only one of those, so that's why I'm only adding one, and so now I'm at a total of 7/8. Now you don't need to walk through the process like I am right now. I'm just showing you how I am getting there, but you can see how this could work in that way. So the next one, I've got 3 different samples that were all 4/8. So again, I could just add 4/8 each time, or I could combine those to begin with. So 4/8 plus 4/8 plus 4/8, and again, notice there's no denominator changing because we've already got those consistent denominators. So 3 4s is 12/8, so I can add 12/8 to my 7/8 already, and now I'm at a total of 19/8, and I'm now done with this column. So I've still got 4 numbers left to add, and you can see that I have 5/8, and I have 3 of them. I'm kind of running out of space here, so I will go to the other side of the page and show you this one. So we've got 5/8 plus 5/8 plus 5/8. Again, no common denominator needed. We've already created that. So 3 5s in this case is 15, and the eighths stays the same. So now I bring that back over and add my 15/8 to my 19/8. And when I do that, I end up with 34/8. All right. And I'm now done with this column. And lastly, I'm going to add one more. I'm just going to do that right here since it's already existing. One more 6/8 to that, and 34 plus 6 equals 48. Now this one works out nice and neatly for us, because as we try to convert that or change that into a mixed number, or in this case a whole number, it goes in nice and evenly. And remember that this simply means that we are taking 40 and we are dividing it by 8 right here. If we want to convert that, we don't want to leave it as an improper fraction. So 40 divided by 8 means that we have a total of 5 cups of food that he ate for the total of 10 days. All right, because 40 divided by 8 is 5. All right, so kind of a messy screen here, and I've showed a lot of work. But guys, this is what you want to be thinking about as you are answering problems like this. Notice I'm taking a lot of the guesswork out of it. I'm taking a lot of the in-my-head work out of it, even though I probably could have done some. By seeing it, I'm allowing myself to see what it is I'm doing and what I've already done, and crossing things off the list as I go. So this last question that we are going to handle for today, guys, says, what amount of food would Toby get each day if the total for 10 days were distributed evenly each day. So this one, we kind of skipped this on yesterday's lesson because it's averaging, which is the same thing here. But now we see that magic word of each. So now we're going to take our total of 5 cups right here, and we want to take that 5 cups and we want to divide it into 10 days. And I know it's been a long time since we've talked about this stuff, guys. I really do. But I'm going to try to pull that back into your memory that when we write something like this, or we write it out like this, 5 divided by 10, okay, we can actually do a problem like this where the smaller number is being divided by the larger number. If I put it in my long division form, I simply add a decimal point and make a 0, and it shows me then that my answer is 10 goes into 50 5 times, or 0.5. We could also do it in fractional form. Remember that this fraction bar also doubles as a division symbol, which is 5 divided by 10, could be simplified down to 1/2 of a cup. So either way, this 0.5 represents a half, and so does the fraction 1/2. So either way we get to it, 1/2 of a cup each day would be the average. Okay? Thank you guys very much. There will be a couple of questions for you to try and solve when you are done with this, watching this video. Please do that. Please do your best to try to answer those questions to the best of your ability, and don't hesitate to ask questions if you have any. Thank you, 5th graders, and I'll talk to you later.